Well, hello and welcome back. We are continuing our series when we're going through MySQL, MariaDB development type things. And we're really just in this episode up to day 8, episode 8, we are continuing, or actually start going back and working through some constraints and talking a little bit more about those. Now, in the last episode, one of the things we did is we moved our tables. We used a create table as select star from, and ended up taking our tutorial 1 and tutorial parent table and basically created address and app user. The problem with those, so if we look at like address, is we didn't get the constraints or anything else. It just pulled the field names, the column names, the type, whether they were null or not, and basically that was it. It may have pulled a default. Oh, I think it did pull a default over, but not in all cases, because let's see, or maybe it did. We will. Oh, it did. So it pulled over the default values. The key, no pun intended, issue with this is that it did not pull across primary key. It did not pull across auto increment, and it did not pull across foreign key relationships. So the first thing I want to do is fix those. The way we do that is we can come in after the fact, and if I can get some stuff out of the way so I can work my mouse, then I can come in here and we're going to alter table address. We're going to do a constraint that we're going to call the address primary key. It's going to be on the T1 ID, and it works fine. We're going to do the same thing, and we're going to do app user. On that one. And so now if we go back to our describes, so if describe address, we now see the primary key is T1 ID, but it's not doing the auto increment. And app user, okay, we've got our primary key. Now, we're going to work on adding that, adjusting that auto increment. A key thing about this is that order matters when you do this. When you create the table from creating it from a query like we did before, where we do something like this, where we just build out our whole table. Notice that we can put auto increment, we can do primary key. So if I want to create tutorial 1 from that, then for some reason it didn't like what it printed, but basically, so now if I do tutorial 1, I'm going to see, boom, I have my primary key, it's auto increment is that extra. Notice if I do describe, what was that, address, so I managed to somehow lose name, because I probably changed over the name, added that later, and I don't have my auto increment. If you do it then, it's fine. If you wait till after the fact, an auto increment cannot be done, and actually I guess you could run into this during the script. An auto increment cannot be added to a non-key. It has to be a primary key first. So we have created those, so we're going to be safe when we do that. We go in here, and we're going to take the table address here, and we're going to modify that column T1 ID to auto increment. And if we describe address, now we'll see that's auto increment. We can do the same thing with the parent ID, app user. And note, we could have gone in, because we've sort of, we're changing stuff on the fly. We could do this and just drop a table and rebuild it. Or we could do alter to column names as well. However, we're still going to have to worry about things like making sure that we get our keys and our primary keys and our foreign keys together. Now, if we wanted to, one of the things we run into is once we start adding data, there can be issues where we can't delete a record because we still have a constraint. We've seen that. Or we want to insert a record and there's a constraint issue. And so one of the things we can do is we can drop a constraint. So let's see. So let's first create a foreign key, because I don't think we have any right now. Yeah, we don't have any. So let's create that foreign key from type ID address. So again, that's what we're going to do. Is we're going to do alter table. That's address. I'm sorry, it's add constraint. And instead of primary, like we did here, primary key, it's going to be foreign key. So let's do foreign, and it doesn't have to be all caps, but that sometimes helps. And so the foreign key is going to be type ID. And we have to tell it what it references. And so it's going to references look up, what's that called? Look up type ID. Whoops. Okay. And now if I do describe address, and I didn't give the constraint a name, which we normally have done. So here, when I do add constraint, I give it a constraint name. I didn't this time. So let's see what happens. What is that? So now if we do select star from lookup type, let's get one that's invalid. So it's 1, 2, 3. So if we insert into address name, cannot be null, comma, type ID. That'll be the shortest one we can do here. Values, whoops. There you go. Got off of that somewhere. So values, address name will be just, whoop, I should hit the right key, delete me. And its type is going to be 4. So this should give us a constraint issue, which is going to. Boom. It does. And now notice it just generated a constraint name. Since we didn't give it one, it generates that. But now we can take that and we can do drop constraint, that guy. Let's come over here and do, just to make sure I get the, I could do if exists, but it should be, so if I go here, oh, it's alter table. I can't do just a straight drop. So I need to do alter table, address, whoops, drop constraint. There we go. So now if I come back and try to do the insert, it allows it. Now let's what happens if I try to create that constraint again. Where was that constraint? There we go. Now I can't because it's going to blow up when it tries to do it because I already have an issue. So what I need to do is select star from. So you don't really want to drop constraints unless you're like cleaning stuff out, or if you know that you're 100% sure that they're going to, if they're getting in the way, but they're 100% sure when you get your data in, it's going to be clean. So I'm going to select star from address. I'm going to delete from address where T1 ID equals 5. And now I can go back, I can create the, there we go, and I can create the foreign key. And I'm also going to go in, let's keep that here. And I also want to do, let me create one real quick. I'm going to alter table. This is going to be app user. Add constraint, and this will be user address foreign key. And it's going to be on the T1 ID. And it's going to reference the address T1 ID. So if I take that, whoops, alter table app user add constraint user. Okay, I did something wrong. Alter table add constraint user address. It's foreign key references Oh, because I have to spell the table right. There. Okay, so now if we look at address, see that we have our auto increment and our primary key. If we look at app user, we're going to see that we have our foreign key here and our primary key. So we're in pretty good shape. So with this, we have got our tables sort of straightened out. But while we're here, let's talk about indexes. When you are doing a search in a database, when you're doing a select with a where clause or an inner join, the value or values that it joins on, the case where you say this value equals that value, when you do that, for example, if I do select star from app user where T1 ID equals 2. I think that's one that's, there we go. So in this case, where I do this T1 ID equals 1, and I guess I'd probably want to do it somewhere, but in searching this, it's actually going to do what's called a table scan. It's going to look through the entire table to find that. Now, one of the things we can do is add indexes. Now, for a primary key, it's already going to be indexed. For a foreign key, it's indexed because it's indexed on the primary key. Your foreign key always relates to a primary key on another table. However, let's say we wanted to do, we were going to search by userLogin, which probably is not uncommon. So what we would want to do is we can do a index. And so we could try create index. Let's see, email lookup on, who's that, app user email. And I think, or sorry, user login. And so now we're not going to see here a difference, I don't think. Oh, yes, it is. It's going to see. So you're going to see that you've got a key there, which is an index, which means now there is a sort of like a table of contents that is going to more quickly direct you to records. Now, when you're talking about a string, it may or may not be useful, although you can use hashes and things like that may get you there closely. But particularly in a number, and a strings, assuming that there's a fairly even distribution and that they are easily found by order. Like if everything starts with A, then it's not going to get you there, or the same multiple letters together. Numbers are usually going to be the fastest because it can very quickly jump to a number via an index. It knows real fast that I'm going to, if I'm looking for something between 100,000 and 100,010, it can very quickly go, oh, I'm going to jump to this index to the 100,000 point and to the 110,000. And that is going to get you huge performance changes as you get into this. When you're using indexes properly, then your queries are going to be really fast. If not, you're going to do these table scans, which means every time it looks for something, it being the database, it has to go through every single record in the database. And that can be very time consuming very quickly. And so it's very useful to note that you can create indexes real quick. Now you don't want too many because when you insert, then all the indexes have to be updated. So you can, that can slow down your inserts. But particularly if you've got a database that is mostly static data or data that exists, and sometimes you're making changes to it, but mostly you're searching against it, or for example, a reporting database, then your indexing is going to be awesome. You want to make sure that that's put everywhere that you are searching for that kind of value, or you can do multi-column indexes, we'll see later. When you do that, if you hit that index, then it's going to be a lot faster. And you can go search like database performance and indexes, show plan, things like SHOW space PLAN. just that, that string, and you will see graphical examples of such things. So you do want to have indexes like in your mind. You can also do, let's say I want, that was email lookup. I want to be email unique. So let's say that I don't want to allow an index email address to show up more than once for an app user. Create index MSC on app user email. All right. So if I do this, then what this does is this means that I cannot add, I will get the same problem I had with the primary keys or the foreign keys when we tried to add, like foreign key, when we tried to add one that doesn't exist. In this email, as you can see, it's got uni, which is unique. So that means if I try to add an app user from app user that has an email address that already exists, so let's say user test 1. So now I do insert into app user. What do I have to have? I have to have a username, an email, user login, a password, and an update date. Oh, which I don't because that's automatically done. So I think I can go with just those values. So username can be anything. So he's going to be blah. This case, I want my email to be this because this is going to blow me out of there. And then user login can be blah, and password can be blah. If I use that, then what I'm going to do is I'm going to see that I get a duplicate entry for that. See, so it's telling me right now that cannot be used. I need a new one. So there's a lot of uses for indexes. I wanted to touch on those before we move on to some of the other things we will touch on. I figured it's a good time while we're cleaning up our data a little bit, our database, that we could take a look at this. That being said, I think we'll wrap this one up. So as always, go out there and have yourself a great day, a great week, and we will talk to you next time.